All right, let's take a look at this limit. We're looking at the limit as x goes to 0 of 1 over x squared. All right, now we can't do this direct substitution because 1 over 0 is undefined, right? And I don't see anything to cancel, right? There's no way to really simplify that 1 over x squared. So let's take a look at what happens when we sneak up on 0. So I've got a table here, and we're just going to plug in values for x and calculate 1 over x squared. So when I approach 0 from the left, it looks like when I plug in a negative 0.1, I get 100. Okay, because I'm going to, it's basically 1/10 and I square it. And then I take the reciprocal of it. And if I plug in a negative 0.01, then I get 10,000. All right, I don't know. Okay. And then when I plug in negative 0.001, I get a million. 000,000. Jeez. Okay, there we go. All right. Now, because I'm squaring the denominator is always going to be positive. So if I approach 0 from the right-hand side with positive values, I'm going to get basically the same thing. I'm going to get 100, and I'm going to get 10,000, and I'm going to get a million. All right, there we go. Okay, so you can see that as we approach 0, those values of 1 over x squared just get bigger and bigger and bigger, right? And we could put even smaller numbers. And you would see that it's just going to get infinitely big. I can choose a number like 0.0000000000001, right? And it's just going to be huge, right, when I divide 1 by that small number. So in this case, these limits are going to infinity, all right? So these are called infinite limits, okay? We have the limit as x approaches 0 from the left is infinity, right? Infinity, we're going to draw a little infinity symbol here. If I approach from the right, I also get infinity, all right? It's kind of like a sideways 8. And then, and they match, right? So the limit as x approaches 0 is infinity. Okay. All right. So that's what we're going to talk about in this section is infinite limits. Now, in this case, both of those limits match. So we could say that the limit as x approaches 0 goes to infinity. They don't always match. And if they don't match, then we just have to say that the limit doesn't exist. But, okay, so here's the definition of infinite limits. If f of x is positive and grows arbitrarily large in magnitude, for all x sufficiently close to but not equal to a, then we say that it goes to infinity, right? This limit as x approaches a of f of x goes to infinity. All right, and now if it could go in the negative direction, right? If f of x is negative and grows arbitrarily large in magnitude for all x sufficiently close to a, right? We say that the limit as x approaches a of f of x goes to negative infinity. Okay, so we can also have a case where the limit goes to a negative infinity. Okay, now in both of these cases, the limit doesn't exist. All right, even though we write it, we say the limit goes to infinity or negative infinity, but technically the limit doesn't exist in either of these cases. There's no finite limit. All right, I'll meet you in the next video.